Hello all. Today we are going to see an amazing file format. What? Wait, what a second. What format? File format. Why file formats? This is something you should be already familiar with, which we discussed in previous video. But you see, there's a data lake, and the fundamental piece of this is cloud object storage. But what we have in cloud object storage, it's all files. So it's not an RDBMS where it says proprietary format, it is just files. So this gives you the flexibility of storing in whatever format you need. But when you store in whatever format you need, there is always a trade-off. So we'll have to understand what we are gaining when we are trying to making some choices. So we are going to see the choices we should make to have an efficient performing data lake and a possible good file format or a good choice for the data lake. Now, this is the typical table structure, which you folks would be already familiar with. But the format which we are going to discuss now is comma separated values, CSV. This could be opened in any standard Excel program. So that's something most of you would be definitely familiar with. But what is CSV? It's a well-known format. Yeah, many people would be already knowing it. The data is actually human readable. So just by looking at it, you can understand the values and all those things. And pretty much it's a string format, like a string or text format, which you can understand. And it's row oriented. So what do we mean by row oriented? That's something maybe we'll have to check a little bit. So this is the same data, just color coded for our reference. So we have only considered 4 columns here: license number, dispatch number, yeah, whatever you see on the screen. So that is the row one, which represents the continuous blocks of data. So when you are actually storing this in the file system, the first row is stored continuously. Then the second row is stored continuously. Again, a CSV file, you might ask, like, we are storing the entire file, but there are other file formats, row oriented file formats, which could typically just store this structure as it is. So the key thing to notice, a row is the group here. Row 1 is the group, row 2 is the group, and row 3, if at all multiple rows exist, they are going to be stored continuously as a group. What is column oriented? As the name indicates, we have flipped the equation. If you notice, no longer we are storing the rows together, rather we are storing the columns together. So license number is stored separately, dispatch number is stored separately, pickup time is stored separately. Yeah. So the column is stored continuously. Why would you do this? What is really the advantage? We will look at one file format of a column oriented and discuss some of the advantages of that. So we are going to look at Parquet, which is obviously, yes, a column oriented format. So first thing, compared to CSV, it's self-describing. If you notice, I had subtly indicated that everything is a text in CSV, but here it's not the case. You actually have a well-defined format. License number is a string or text. Pickup time is actually a timestamp or a date time field. Pickup location ID is an integer. So Parquet actually stores the data type, or in other words, the schema in its own its own file footer. So we will look at what is footer in the subsequent slide, but just the takeaway here is Parquet actually stores the data type of the column in its file. So you really know what data type it is. Second advantage, compression. This is critical because you are going to ingest a lot of data in your data lake, and you want the data lake size to be like not growing very huge, right? You just want to have it in a sizable way, because in cloud-based environment, you are also going to, your costs are also going to get increased based on your storage. So that gives this particular advantage. How does it do compression? How does Parquet handle compression? Let's take a look. So what you see is, this is called dictionary encoding. So instead of HB003, you can encode it as a number 1 and actually store the number 1 value. In similar lines, HB005 can be converted as to number 2 and stored in the file. So this dictionary is also maintained as part of the Parquet file. Again, I have been saying about Parquet. Parquet is also a binary structure. So it's not like you open Parquet, you are going to see some of this data. So it's able to do all of these optimizations. So it's definitely not human readable. It's a binary format. So it stores the dictionary information as part of the file and also the actual data in this way. So the number of bits to store HV003 has been now reduced. It's now like only 1 bit. So that's a huge amount of savings. For 2 records, yeah, it doesn't make much of a difference. But you have like millions records, billions of records, the size savings are going to be huge. Let's look at one more way of compressing. I would say it's an additional way of compressing on top of this. So it applies run length encoding. What we saw earlier was dictionary encoding. Now we are going to see run length encoding on top of dictionary encoding. So this is the dictionary encoded form, but then it compresses it even further. So here we have 1, then there are 2 2s, and then there are 2 1s. It just stores the data in the same way. So 1 1, 2 2s, 1 2s. So whenever there's a continuous data being repeated, it just encodes based on the length of the run. So that's like run length. So you see multiple things. Yeah, the name is self-explanatory. So that's why it's called run length encoding. This would be very useful for sparse data because, I mean, what do you mean by sparse data again? You don't have values for many of the rows. So there is like null or empty. So that's typical scenario, right? In one of one of my projects, we had a situation of like most of the data being sparse, since that the values will not be there for many columns. So when we used Parquet for that, right, 1 gig data, 1 GB data was actually compressed as around like 100 MB data. So we didn't actually even realize that benefit when we are trying to decompress it. For some reason, it was failing for this space issue. Then we noticed it was doing a huge compression here, and it was amazing because that actually reduced the, I would say, even the storage cost. So that's the amazing power of compression with Parquet. But compression is not the end of the game. We should also need good performance. So what does this do? So this on the right side, what you see is a typical structure of Parquet. So this is the footer, which I was kind of hinting earlier, and then this is the actual content. Parquet stores some statistics about your column in the footer. So basically, it says what is the total number of records. For example, if the file if this file contains 100 records, it would say the count of records is 100 here. How much? What is kind of the average of that 100 records for that particular column? What is the sum of those? Some common statistics which you might look for in an analytical world are automatically computed while writing the data and stored in the footer. And the way the data is organized, as we are saying, it's columnar storage. So you have columns stored separately like this. I mean, row group is a concept of like, if you have 1,000 rows, there might be 10 row groups, one row group containing 100 records. I mean, just an analogy for you to kind of relate to. But yeah, it kind of does some sort of grouping of rows, and within those row groups, it's stored in columns. So again, there is data, which is the actual data. Definition is what we were using for the dictionary encoding, and header is obviously like what type and all those things, some of those aspects, and repetition is also there, how much times some of the values are being repeated. So this gives into a way improved performance when you are trying to access only particular columns. So if you are kind of, I mean, if there are 100 columns and if you're just trying to access only 10 columns in a row oriented format, you have to read all the 100 columns, because if you remember, the row is stored as it is. So even though you don't need the rest of the 90 columns, what really happens is it reads all the columns, and then from that it filters out what are the 10 rows you need. But here the opposite thing happens. It just fetches only those columns which you query from the file system. One example I would like to share from my experiences, We were actually doing this in kind of an AWS platform, and we were running Athena queries. We had around like some of the queries running for 30 minutes. The earlier version was predominantly using JSON, not CSV. JSON is another file format. And obviously it's also a little bit row-oriented format. So it was not giving us a very good performance. So many queries were running for more than 30 minutes, and Athena used to time out after 30 minutes. So we kind of used Parquet for that use case. And what we realized is like 30-minute query actually was running less than a minute. So somewhere around 15 to 30 seconds, that was what that query was actually taking. That was like really amazing for us. And that led to us adopting Parquet as the standard file system for our data lake. Now, all said and done, can we see a small demo of what we have discussed so far, comparing Parquet and CSV, and now really it matters. So I'm going to use Spark for demonstrating that, but it is just another processing framework. You could use anything for that. Just that I'm comfortable with Spark. So you have 5 CSV files. Actually, it's one CSV file replicated 5 times. This is newer taxi data. And it does have like many columns. Again, as for the example, I've just taken 6 to 7 columns, and we have files. It's the same file, just replicated 5 times. Now, the data in CSV is 3.68 gigs. When I try to convert it in, the record count is around 58 million records, and I try to convert it into Parquet, the size is 850 MB. You can imagine the size savings, right? As I said, yeah, this is something definitely Parquet is going to do. If you're converting from CSV data or JSON data, that's going to be like the best compression in Parquet. We'll also look at the performance aspects. I've just already run the program in order to save time. So I have just done a simple query of all the writes. So it takes 1.21 seconds. Hardly kind of like 1 second is nothing. Yeah, it just does that. We are not looking for it can be even more better. I see it's 1.21 seconds because there are some setup time and all those things. Ideally, if you are running in a data lake environment, it will be even lesser. Now, the second version of the query, what I did was I took a column, pickup location ID, and I'm grouping all the writes based on pickup location ID. And you see the time taken is 2.4 seconds. Really fast, not bad. Now, let's see what CSV does. The count query, which I did, CSV took around 5 seconds. Parquet did it in 1.2 seconds. You can see the difference. You can say it's all seconds, but with the amount of data and with the distributed data and ecosystem and all those things, this 2x, 3x speedups is going to be way huge. So right now the data is small. It's like, and I'm learning in my local. So there are obviously some factors due to that, but 2 to 3x is, I would say, like very huge. Now this is, I wouldn't say not the big deal. When we did the column access, you can see that CSV is somewhere around 13 seconds, whereas Parquet is somewhere around 2.5 seconds. So you can say like 2 seconds and 13 seconds. Imagine the speed of 6x. So again, just in a single machine, if it is 6x with distributed data and all those aspects, Parquet is going to be like way faster. So definitely I would recommend using Parquet as a column node format for data lakes. So obvious question is, can I use Parquet everywhere? Because that's what you said. So we will see that. So when to use? Yes, it offers good performance and compression for huge volume of data. When the data is huge and you need good performance and good compression, yes, Parquet can be a good choice. When you are accessing only few columns of the data set, again, when I say 4 out of 10 is not really that few, it's like 20 out of 100, 30 out of 100, something of that sort. We have like huge set of columns. So imagine this is not OLTP world, the transactional world, it's the analytical world. So you are going to have a very huge set of columns in your data set. Read heavy workloads. So it's not that you cannot use it for write heavy workloads. It's optimized for reading, but typically in data lakes itself, updating the same file is not a good thing. So you want that immutable stuff. So put once in the data lake, read it multiple times. So write once, read many. The acronym is WORM, WORM, write once, read multiple times. So it's good for multiple read heavy workloads. For write heavy, it's not recommended in the sense that if you're updating the same file, it has to compute the statistics in the footer. It has to do all the fancy stuff which we discussed earlier so that the read performance is good. So you are going to suffer a little bit of write overhead. So that's why it's more suited for read heavy. When not to use, it's very important. And the data volume is very low. So if your entire kind of the data set is like close to 2 GB, it doesn't matter that much. Doing all of this fancy stuff may not matter. It might be good to have it in CSV and JSON. Go ahead and play with that. I mean, keep it simple. That is a standard software acronym, right? So in that sense, don't kind of bother with Parquet if the data volume is low. Always all columns are accessed. Again, if the data set itself is 10 to 15 columns, I mean, I showed you a data set with 7 columns. You can see only 3x or 5x performance improvement, even in the 7 columns or something. But for those use cases, again, Parquet may not be an ideal choice. It might be better to go with stick with other file formats. I mean, not necessarily CSV. There are also row-oriented file formats which you can try to use. So make a wise choice. Again, Parquet is definitely an ideal choice for a huge data lake with lot of read operations. So I would definitely recommend you to explore Parquet, but it's not the only file format which you should use. So with that, we come to the end of today's talk. Please provide your comments, feedback, or what you want me to cover more, and please subscribe if possible. Thank you.